Chapter 3.1, Functions and Functions Notation. This is page 6 of the notes. So we are going to move on from functions to a specific type of function. That is a function that is one-to-one. So a one-to-one function, well, you don't need me to read the definition. That is there. A one-to-one function basically means if I give you an x, you can tell me specifically what y that will produce. If I give you a y, you can tell me exactly what x produced that y. So one-to-one correspondence, each x has one and only one y, and each y has one and only one x. So let's take a look at example 13 here. We're on A function f is one-to-one. If different inputs have different outputs, that is, so here's how we're going to write it. If x sub 1 does not equal x sub 2, those are our different inputs, then f of x sub 1 does not equal f of x sub 2. And so we're going to go with two examples here. I want to make sure you have an example of something that is a one-to-one function, and then an example of something that is not one-to-one. Because a lot of times we crank out these examples that prove our point, and then we get something that doesn't quite work, but we're not sure what it is we're supposed to be looking for. So here's our one-to-one. We are going to say f of x equals x to the third. One-to-one, not one-to-one. Okay. And so we need two inputs. We need two x's that are not equal. So we're going to choose 4 not equal to negative 4, right? Those are not equal. Then f of 4, which would be 4/3, is 64. F of negative 4. Careful about the parentheses here. I'm going to wrap my negative 4 in parentheses because I want to show that that is negative 4 times negative 4 times negative 4. I get negative 64. Okay, so we chose two x's that are not the same. Then f of 4 does not equal f of negative 4 because 64 is not equal to negative 64. Let's take a look at a function that's not one-to-one. Let's slide this over here just a little bit so I can get that in here. So we're going to call g of x x squared. And guess what? We will use the same x's. We've got 4 not equal to negative 4. But g of 4, which would be 4 squared, which is 16, would equal negative 4 squared, would equal g of negative 4. So I can show that my inputs are not equal. 4 is not equal to negative 4, but those outputs are equal. They both equal 16. So it is not one-to-one. Okay, and let me stick a box around this. When you come back to look for it, kind of stands out. B is a different way of looking at this. A function is also one-to-one if when the outputs are the same, the inputs are the same. That means that if f of x sub 1 equals f of x sub 2, it must be because we started with the same inputs. Okay, so let's take a look again. We got two examples. We got one that's one-to-one, and then one that is not one-to-one. So our one-to-one function we are going to call f of x equals x to the third plus 1. And so I am just going to choose an output. So we're going to let f of x sub 1 equal -7 equal f of x sub 2. And so now we're going to go ahead and solve. X sub 1 cubed plus 1 equals -7. X sub 1 cubed equals, subtract 1 from both sides, we get a -8. Cube root both sides, that is a negative. And x sub 1 equals -2. You notice there is nothing else that can be. So if we do the same thing over here, but we call it x sub 2, right, you know what's going to happen. X sub 2 equals -2. Ooh, I lost a negative over here. So if my outputs are input, it has to be because if my outputs are input, if my outputs are equal, has to be because my inputs were equal as well. So not one-to-one. Let's go g of x equals x squared minus 1. So I got g of x sub 1 equals, I don't know, how about 3? G of x sub 2. I can go x sub 1 squared minus 1 equals 3. X sub 1 squared equals 4. X sub 1, I just want to pick one solution. I'm going to call that positive 2. And you guys know where I am going with this. X squared equals 4, x sub 2. And so x sub 2 could be -2. So let's take a look at how it worked on the left here, if it is one-to-one. If f of x sub 1 equals f of x sub 2, then we showed that x sub 1 had to equal x sub 2. Over here on the right, we started with g of x sub 1 equal to g of x sub 2. But, and this is a big but, x sub 1 does not equal x sub 2. Okay. So there's our one-to-one functions. So example 14, we're asked to show that the function g of x equals 3 times the quantity x minus 5 squared plus 7 is not one-to-one. So we're going to pick an output for g of x. We are going to, let's go back to the blue. We're going to let g of x equal 34. And all we need to do is show that there are multiple inputs that give us the same output. So are there two separate x's that make this true? Now you can kind of go with your gut. You know that we have that x squared in the equation. So chances are we are going to have some sort of plus or minus in our answer. But let's see what we got here. So we're going to subtract 7 from both sides. That gives us a 27 equals 3 times x minus 5 squared. Divide both sides by 3. I get 9 equals x minus 5 squared. And then if we take the square root, because we're imposing that square root on our own, I get x minus 5 equals plus or minus 3. So that gives me two equations to solve. X minus 5 equals positive 3. And x minus 5 equals negative 3. Add 3 to both sides, I get an x equal 8. Sorry, add 5 to both sides, and I get an x equal 8. Holy moly. And 5 over here, and I get x equals 2. So there are two different x's that come from this g of x. So we got g of our first x equals 34, which is g of our x sub 2. But x sub 1 we can call 8 does not equal 2, which is our x sub 2. So we have shown that this is not one-to-one. Boom. Very bottom here, we've got this Roman numeral 4. Use the vertical line test to identify functions. Okay. A vertical line test means any x gives us only one y. And all of those problems are on the next page. So we are going to stop this here, pick it up on page 7.